Okay. Today we're going to talk about design considerations for manufacturability. Let's take a look at this video here first.
MDS SciEx of Toronto is pleased with the results it's reaped with a disciplined approach to design for manufacture and assembly.
It provides us with a mechanism to ensure that the pieces do fit together.
To make sure they fit together easily, MDS SciEx asks its designers to follow a few simple guidelines. Reduce the number of fasteners, both in type and their overall number. Fewer types of fasteners reduce the number of parts that the company needs to carry in inventory and track. And fewer fasteners in the product have two more benefits. Technicians spend less time inserting them, and the company needn't buy as many parts. Use unique orientations. Designing subassemblies to fit together in only one way is a great quality control technique. Products are assembled the right way every time. Design features for alignment. A self-aligning assembly improves quality and saves a tremendous amount of time in assembly, installation, and service. Make parts and features accessible. Easy access improves speed and quality in manufacturing and service. A prime example of the results that following these guidelines can produce is the API 2000, a triple quad mass spectrometer that was the most powerful on the market when it was introduced by MDS SciEx. The key to this success is a modular design that is self-jigging and self-locating while containing only a few fasteners and soldered joints. The modules also go together only one way, eliminating any ambiguity in their assembly.
All right, now we're going to look at mass properties. So one thing you want to consider when you're designing things is the volume. How much raw material must be purchased? When you're going to make a product. Also, should take into consideration the surface area. How much might it cost to coat or paint the surface? And then the density. How strong is the material? What machines are needed to process it? And then finally, the mass. Because weight determines how much it's going to cost to transport that material. So you might want to take a little bit of notes on that thing there. Just make sure you get that into your notes there on that document that you made the other day there. So moving on, when you're choosing your materials, it's important to take into consideration the following here: strength, durability, cost, availability of the material, and then environmental impact, finishing cost, shipping, and transport. So we're going to talk about all these things here. First, looking at strength and durability, will the product be strong enough to perform its function, but not over-engineered at an increased cost? So, many times engineers will need to take into consideration the durability of the material. Are they over-engineering it? Because that would waste some money, so we don't want to do that. And so they might define or decide to design a product to last a certain amount of time, not forever, just to keep the material costs low. So then the question is, will the product perform over time, or is it designed or created to have a designated lifespan? So remember that little pump toy that we were looking at the other day? That might be only designed to last for maybe through a birthday party. And that's great, because then it could break, maybe it costs just a little amount of money. Now let's look at cost and availability. So how much does the raw material cost? A big question there. Will the raw material make the end product too expensive? Another thing to look at is the material available, or is it a limited supply? Will the raw material need to be shipped to the factory, or will it be available locally? So if it's cheap, but you just can't get it, then it's probably not a good material, because you just won't have it. It won't be available. Let's look at environmental impact. Making ethical material choices is often more expensive, unfortunately, for the manufacturer. So one thing that they need to consider is, does the manufacturing process create pollution? And many of them do. Then what will happen to the excess material from manufacturing and the product at the end of its life cycle? Is it going to end up in a landfill, or is it possible that it could be recycled? So these are some environmental impacts that an engineer might want to consider when they're designing a product. And then last is shipping and transport costs. How much does the product weigh because lighter products and lighter parts are less expensive to ship. And then what equipment is required to move and manipulate the parts during manufacturing? If you have really heavy parts, it's going to take some pretty hefty and strong machinery to move that stuff. If you have a really large part but it's light and you want to ship it with a plane, there's only so much space in those planes. You know, you've been on one of those before maybe, and so you know that it would cost more to ship it because you can't get as much stuff in the plane with big parts in there. So let's take a look at this ergonomic safety video. So the last thing to maybe add some notes on is the consideration that manufacturers have to think about for the safety of their employers. You'll see a little bit on this little here, and this little thing, how it needs to be in the right position. Buttons can't be too hard to press, so you might want to add some of those notes into your presentation. I think that
Proactive is the key word at John Deere Davenport Works in Davenport, Iowa. John Deere is the world's leading producer of agricultural equipment and a major producer of industrial equipment, employing about 34,000 people. When it comes to ergonomics and safety, the safety director says it's as simple as a walk through the plant.
But I really think that it's really important that we spend time on the floor with our employees, asking them, what can we do to make your job safer?
On his daily walks through the plant, he can identify ergonomic and safety concerns before they become a problem. By talking with employees, he taps into a ready resource of practical information. When a new process or product is introduced, the workforce is informed and encouraged to get involved in the changes. The facility's approach to problems is to rank any safety concern by the following criteria: force, posture, repetition. The jobs ranking highest in these areas will get attention the fastest. Solving existing problems continues to be a major focus of the safety department. One of the first issues addressed was a problem with air hoses stored on the floor. It was a safety concern because workers would trip over the hoses, and if cut, the hose could release high-pressure air, a potentially dangerous situation. There was an ergonomic concern as well. The air hoses run the pneumatic equipment. Every time a hose was used, it was manually lifted and moved. Employees complained of upper back problems.
So what we really wanted to do was take our hose and get them up off the floor. So we designed in-house here a spring-loaded device which actually holds the hose up and it retracts, not in a coil, but similar to that of a fishing pole.
Another ergonomic project was replacing existing hoist pendants. The hoist pendant used to guide heavy products was almost as difficult to maneuver as the item being moved. The pendant was 4 inches by 4 inches and weighed about 13 pounds. To push the buttons required 5 to 10 pounds of pressure. Operators complained of thumb cramps and stiffness.
So by looking and challenging some of our suppliers, we were able to find a pendant available on the market that came pre-wired and cost almost exactly the same as the large pendant and had great durability.
The new pendants are smaller, lighter, and easy to hold.
I think that's it. It looks like we're done here.